Hello and welcome. My name is Benjamin, and today we'll be designing a raft foundation on Protastructure. I'll be teaching you guys step by step on how to design a raft foundation on Protastructure. Before I dive into the video, I would really like to apologize. This video ought to have been out before now because of the request, but uh, time has always been the factor. Really sorry, but I'm going to take you guys step by step on how to design a raft foundation using Protastructure, and by the end of this video you'll be an expert in designing raft foundation on Protastructure. So let's dive right into it. I already have an existing model I would like us to use. This is a hostel. This is a one floor hostel. I would like us to use a raft foundation to design this hostel. Now to do that, I'll just go back to I'll take this as I'll go back to my ground floor, which is the plan, and these are all of my columns. This is my story. This is my story 0. This story 0 plus 50 meters. This is my ground level. So to do that, I will come to my beam. Now there are different kinds of raft foundation. We have the beam raft foundation, we have the slab raft foundation, but this tutorial will be talking on how to design a beam raft foundation. The design of beam raft foundation and slab raft foundation is not once you can design a beam raft foundation, to design a slab raft foundation won't be an issue. So to do that, I will be putting beams to connect all of my columns together. So I will just I'll take my beam width to be 230, and I'll take my beam depth to be 1 meter as 1000. Now you can see, let me go back, let me shift this here, let me go to first floor. So now you can see first floor. This building has already been designed. The superstructure has already been designed. You can see this is our slab strip. You can see the slab has also been designed already. So I came to story 1 so that we can see how the beams are connecting each other, because we can't just start putting beams anyhow. We have to know how the beams are connecting each other, so we won't end up putting beams in location that they are not supposed to. So this is my story 1, and to make this easy, because I won't want to be switching all the time, I'll just take a picture of this. I'll just take a picture of this on my phone, then I'll be watching it on my phone. But if you can still divide your screen into 2 and be designing on Prota one side and be looking at it the other side, is still fine. So I have got it already on my phone. So I'll go to story 0. You can see my story 0. This is the foundation level, and I'll activate my beam. This is my beam width. So my beam depth is going to be 1 meter. My beam depth is going to be 1 meter, and then I will start putting them. Now I'll click on this column to this column to this column. Now to be fast, I can still click on this and drag to the last column and drop it. I'll come here, do the same thing. Remember, I've already taken a picture of this, so I am looking at my phone and connecting these beams to the columns the way they should be. So I'll come here, escape, I'll connect here. This is our staircase region, so I'll just go straight, stop here, come here, I'll connect here. So I'll connect from here to here, connect here, I'll connect here. Okay, I'll connect here. I'll connect from here, I'll drag to here. I'll do the same thing from here, I'll drag to here. So from here I'll connect to this column here, connect from here to here, connect from here to here. So I urge that you use when you're designing for your raft, you have a plan already. You'll be watching the plan while you're doing the design. So how is this one? Okay, this is also coming here. Okay, I'll connect here to here. So the connection of beams to our columns normally take time. So just take time and do it, so that we'll have an accurate work. Make sure you're snapping at the center of the column, so that you won't have any of your beam deviating. So connect from here to here, click escape, connect from here to here, click escape. Okay, so connect from here to here, connect from here to here from the design. So we are done already. You can see everything has been connected. So let's go to, so you can see our foundation beam 1, foundation beam 10, foundation beam 11. These are FB means foundation beam. This is the structure tree. This side of the software, this is the structure tree. So you can see FB means foundation beam 1, foundation beam 10. This side continues. So let's go to the 3D view and see. You can see our foundation beam. You can see how everything is connected. Let's take a look at the plan view. Let's look at the plan view at story 1. You can see the connection, exactly what we've done. So let's just go back and continue, so we don't waste time, so that this video will not be too long. So after putting our foundation beams, we'll go ahead to install our slab. So this is slab here. Click on it. Now my slab, this building is designed according to BS standard. So my slab, okay, this is loading. My loading has already been defined. So my slab depth, now for raft foundation, your slab depth starts from 200 mm and above. That's 20 cm and above. 20 cm and above for your raft foundation. So this is a beam raft foundation, but it's carrying a slab. Beam raft foundation, but it's carrying a slab. So our slab depth is going to be 200. Concrete cover, I'll make it 50. Then now the type of slab, always leave it on 1. Then we'll just start placing them. We'll click here, click here, oh, okay. Now I think I made a mistake. Now let me tell you the mistake I've made. Now let's go to 3D view, so you can see the mistake that I have made, and we'll correct it. Now in 3D view, now you can see that our slab, the one that we've applied, is currently at the bottom of our foundation beam, which is not supposed to be so. this slab is supposed to be at the same level with the foundation beam, because the bottom, the back is going to be backfill, our hardcore will also be there, so the slab should flush at the same surface with this uh uh foundation beam. So to do that, I'll just go back to story to my plan view, and I will delete this slab because I won't want to be correcting each of them one by one. I'll just go back, delete all of them. So let me exit. I'll delete. Okay, to delete your slab, you don't have to be clicking on one by one. Just come to here, your structure 3, this area. You click on the first one, then come down, click on shift and click the last one. Then you can click on delete and you delete. Now we'll come back and apply our slab properly. We'll click on slab. Depth is 200. If you put anything less than 200, it's going to fail, and it's not going to work. It's going to fail. But you start from 200. If it fails, you give another depth, or you go and change the slab that fail. You increase the depth of the slab that fail. So this is 200, and I will leave my concrete cover for 50, or let's just take it back to 25, the way it is. Then now come to load. Now this this relative level, it's telling you the level at which you want your slab to be positioned. Now our beam depth is 1 meter, and our slab is 200. So let me bring up my calculator. So do this together. So I'll just come here and search for calculator. I know it's a very simple math, but I want us to do it together. So my beam depth is 1 meter, that is 1000 millimeter, right? Minus my slab thickness is 220 cm, which is equivalent to 200 millimeter, equals to, so our slab level is going to be 800 millimeter. This 800 millimeter is the level at which the slab is going to flush exactly at the surface of the beam. So I haven't done this. I'll just minimize this, then come here, put 800, come to general. This is it. Now we'll start placing. Let's place this side. So when designing for Raft foundation takes it takes time to design. So this is it. So let's close this and let's check our 3D view and see what we have. Now you can see our slab is now flushing at the same level with our ground beam. So you can see this back is going to be backfill. We'll backfill this back. We'll put our hardcore, then we'll put our membrane, then this slab will come on top. So that's that about that. So let's go back to the plan view. So this is the plan view. We'll be putting on our slab strip. Now while we're putting on our slab strip, after this design, we're going to detail this building using AutoCAD or any CAD software you have that can give you a very good detailing, a workable or detailing. So we are going to be applying slab strip on this slab so that we can get the reinforcement, the amount of reinforcement and the size of bars that we are going to be using for this slab. So let's apply our slab strip on this slab here. Now to do that, I'll come to my slab strip. This is this layer. I'll left click on it. Now I'll start with my x axis. This is my x axis and this is my y axis. We have done this already. We currently have a masterclass course on how to design. In that course, we'll teach you how to design everything you need to know about structure using Protastructure. We've done this already in our class, so I won't really be explaining in detail on how to apply slab strip. So to apply slab strip on your design, we've already selected that we want to apply for the x-axis. Now mind you, this is the foundation slab, so we are not going to leave it at analytical strip. Analytical strip is used for our floors. Let's say our ground, our first floor, like our story 1, our story 2 we use analytical slip. But when we're talking about foundation floors, foundation slab, we use what is called FE strip. FE strip, there is finite element strip. I will do a separate video another time to explain what FE really means. So we'll choose FE strip. Now this means this is starting from out of the slab and ending out of the slab. So I'll just click and I'll hold my control so that it's going to be straight at an angle 90. I'll click, I'll apply my slab strip at the X direction, click, I'll click, is already on out to out. So control, you hold control so that it's going to be straight. This is a hostel design. Now before you select Raft foundation as your foundation choice, it must be so I'll click here. Now I'll come back to X direction, that's the vertical. I'll click and it's still the same thing as out to out because I'm starting out and ending at out. So I'll click here, control, click, I'll click here, click here, click here. Make sure you hold your control so that you can draw your strip very straight. Now before you select Raft foundation, whether beam Raft foundation or slab Raft foundation, your soil bearing ratio must be less than 75 kilonewton per meter. When you have anything less than 75 kilonewton per meter, you can select Raft foundation depending on the location. But in all of your design, you first of all start with a part foundation. Part foundation, when your design is above 75 kilonewton per meter, you can use Raft foundation. So we have successfully applied slab strip. So we'll just close this. Now let's view this in 3D. The more you're adding element, the more they are applying here, and the more is making this place choked up. So this is 3D. Now we'll be applying what is called a toll on this beam. Now when your beam depth is more than 900 mm, it refers to as a wall. It refers to as a retaining wall. And for you to have for your designs to be effective, this retaining wall need to have a toe. The toe of the retaining wall helps overcome what is called overburden pressure at this end here. So to apply a toe on your wall, we'll go back to the plan view. Now this is it here. I'll come to slab, and I'll click on count. I'll click on 12. Now this is 12. Now the depth is going to be 200. Now the length of cantilever, I'll choose 800. Now your toe start from 50 cm to your toe start from 50 cm or 50 cm. That is equivalent to 500 mm or 1000 mm and above. I'll be using 800 mm as the length of my cantilever, because the toe is just in one direction. So having done this, I'll start applying my toe. I'll click here, click outside, click here, click outside. The design of Raft foundation takes time. Design of Raft foundation takes time, but you just have to do the right thing. You just have to take your time and do the right thing. If it was part foundation, would have been done by now. If it was part foundation, by now would have been done. So I'm applying toe. This is called a toe. Okay, this is wrong. This is called a toe. So I'll keep applying. I'm applying the toe. I will try and share a side picture of what a toe looks like. I think I took a picture of how it looks like so that I can show anyone that is confused of what a slab toe means. Once your beam depth is more than 900, you design it as a retaining wall. And that is what we are doing. Designing Raft foundation. So after this, let's go to 3D and see how our toe looks like. 3D view. Now you can see this is the toe. You can see this. This is how it is. This is how it is. Now this place is going to be backfill before the slab, and the pressure that is trying to pull this wall apart is going to be high. So this slab toe helps prevent that from happening, because it's going to be, from the detail, is going to be, we're going to the reinforcement of this wall and this toe is going to be connected to each other. So it's just going to be something like this. So it will be difficult for this thing to twist when this slab toe is here supporting it. So let's go back to floor plan. So having done this, we'll go straight to, we're done with this. Let's close this. We'll go straight to analysis. This is analysis. Now please don't click on building analysis direct. We are using a finite element raft foundation analysis. Finite element raft foundation analysis. We'll click on this, and if you're designing for a raft foundation for the first time, this is not going to be checked. This is not going to be checked. These are the only two things that are going to be checked. But if you want to design for raft foundation, you make sure you click on this, the use of subgraded reaction. This is surcharge coefficient. Please don't tamper with this. We'll apply this. Apply live load reduction or combination. When you've tick all of these things, please do not tick on use sparse solver for finite element floor analysis. Please do not tick on this. We use this sparse solver for high-rise building. If you tick on sparse solver, you might run into runtime error, or your analysis, you might be encountering errors, and it might lead to termination of your design. Before we go into this, I would like to save this work. Let me just cancel out. I will click on save project. Please, whenever you're designing on Protastructure, it's very good you save your work as you advance step by step, because you never can tell when your device will run into runtime error. And once your Protastructure or any other software runs into runtime error, you only have two options: click on OK or cancel. And whichever one you click, the software is going to terminate at that time. And if what you've done so far you did not save it, you are going to lose all of that work and you have to start again. So having saved this, we'll come back to analysis, click on finite element. We have already ticked on this, so click on Raft foundation mesh and analysis. So I'll left click on it. Finite element mode exists for this floor. Do you want to replace it? Now I've already done this. I've already done a raft foundation already for this structure, but for the sake of this video, I decided to start all over again. I deleted it and started all over again. That's why it's showing me that FE model exists for this floor. Do you want to replace it? So click on yes. But for you that is running Raft Foundation for the very first time, you're not going to see that option. It's just going to come straight to this place. So when you're here, you click on generate model. You left click on this to generate model and you wait for it. You can see processing plate element. You wait for it to generate the model. And please make sure your system is kind of strong when you want to run a Raft analysis. When you want to run Raft Foundation, you don't want to collect a project on Raft Foundation, and it depends on the magnitude of the building. It might be very the building you're trying to run a Raft Foundation might be big and contain a lot of elements, and you need to use a Raft Foundation to design it. And if your system is not strong enough, it can even lead to crashing of your system, or it can take a very long time. My PC is fast, quite alright, but due to the fact that Raft Foundation takes so much of your RAM, and you can see it's still delaying at some point. So having done this, I will just close here. I'll come here, close here. Now when you close, don't press anything, just wait for the program to, you can see it's loading, calculating the member result. Don't click on cancel, just wait for it to calculate the result. Now after that, it will pop you to this page. Once this dialog box appear, click on analysis post processing. Click on analysis post processing. I will left click on it. You left click on it and you wait for it to load. Wait for it to load. My system is making lot of noise now because of the Raft Foundation. It's taxing my system. So when if your PC is not strong, if you get to this place, it's going to be hanging. So you just have to be careful, and be careful on how you zoom. You might zoom too much and run into runtime error if your PC don't have very good graphics and it's kind of slow. So when you're here, you click on standard contour. Click on this. Do not click on use define contour. Do not click on threshold contour. Click on standard contour. So I will left click on standard contour, and once you left click on standard contour, this thing will appear here. Now when this appear, we are going to start. We'll click on this bending moment to apply. Now we are trying to design this slab, so that because this slab is going to transfer load to the foundation beam. After we design this slab, we are going to now design the foundation beam, because the load would have been transferred to the beam already. So we'll come to this place. Now this is bending moment. We'll come to this place. Now make sure this mouse is touching. You can see my MX, you can see a line. If I take this mouse off, no line. If I bring back the mouse, you can see a line appear. You left click on it and wait for it to load. Now if you click on it, put your eyes here. This is the minimum, this is the least or this is your least moment, this is your maximum moment. And mind you, your M max is always more than your M minimum, so always put your eyes on this place. Now we are done with MX. We'll come to MY. left click on it, and the effect has applied. We'll come to MXY, left click on it. You can see our M max is always more than our M min. Now we'll come to bending moment here again. M1, we'll left click on it and wait for it to load and apply the changes on this. As you're clicking on this, you can be seeing the changes applying, taking place here. We'll come to M2, click on it. We'll come to M12, click on it. Now we'll come to design moment, come here, click on this. We'll come to the next one, MD2 bottom, click on it. Come to this one, MD1 top. Come to this next one, click on it. Now this is the proper way of designing raft foundation. You're trying to apply all of the load on it so that your building will be safe, and when after designing it, you'll be comfortable that yes, nothing can happen to that building. Now you come to required steel. We'll click on this, click on it, and to apply. It's from all of this information that we're going to get the bar size that we'll use for this this slab. We'll click on that. Now come to AS required. We've done for AS required bottom. This one, AS required bottom 2. Now this is this thing is a top and bottom. You have a top and bottom mesh. A top and bottom mesh where you have the bottom reinforcement running in X and Y axis. You have the top reinforcement running X and Y axis. Then you have a chair in the middle. A chair in the middle. So we'll click on this here. AS required top. Click on it and allow it to load. Now when you get to this required steel area, if your slab depth is not sufficient, you're not going to be able to continue, because it's going to be showing you an error message that you should go and increase the section of that slab. So it's not going to continue. But if your slab depth is sufficient, you are not going to get such message, just like we are having here. So we'll click on this again, AS2. Now this has all been applied. Now when all of this is done, come and click on soil pressure. We'll apply the soil pressure on this. Now please, when you're here, don't mistakenly click on soil pressure threshold. Now soil pressure threshold is when you're using this threshold contour, and for this beam raft foundation, we're not using threshold contour, we're using standard contour. So you will click on soil pressure, we'll left click on it and we'll wait. Now this soil pressure can take as long as possible depending on how fast your PC is. At times it can even take up to 30 minutes if your PC is even low, up to 1 hour. I'm not trying to scare you, but when you're trying to run, before you get any project that you want to run, any of your design project, try and weigh the magnitude of the project you are to design and compare to your PC. Then you know how to charge for that project. Because if you take a project and it end up crashing your PC and you're not done, you are the one at the losing end. Now you can see our design is okay. Our soil pressure is 280, which is okay compared to the pressure from our building. Now this is the maximum pressure coming from our building, which is 54.955 kilonewton per meter square, and this is our soil pressure. This is very okay. So when you're done, now export contour. will not be exporting contour. You only export contour when you're dealing with high-rise building and all of that. But this is just a very this is just a hostel. It's just a one suspended floor hostel. So we'll not be exporting contour. So when we are done with this, and now this thing okay here tells you that your raft foundation has been designed successfully. Now from here you can go on with a smile on your face that yes, your raft foundation is safe, and whoever the contractor you give, you will not be scared. And even when they have built the building, you can probably go there, stay inside and say yes, you designed this building, and nothing can happen to it. So when we are done with this, you come here and click on this, cancel, and a dialog box appear. Now you can see these are the slab strip that we applied before we started the analysis. Transfer slab strip finite element analysis result. Now this final element is going to transfer the slab strip that we apply to the slab. Now when we transfer the slab strip, we are going to know, it's from this slab strip that we are going to know the area of bar we are going to use and the spacing. So when you get this dialog box, click on OK. When you click on OK, you wait for it. Transferring slab strip. So you wait for it to transfer the slab strip. So it's transferring slab strip. We have a design course on Protastructure. It's a 7-story commercial building. If you've not and if you're interested in learning structural design, you can drop a comment, and we will take you step by step on how to design using Protastructure and even advanced. So this is it. When you're done with this dialog box appear. Click on transfer foundation beam result. Transfer foundation beam result. So I will left click on it, and when you left click on it, you get something here saying foundation beam finite element result are transferred. So when you see this, you just come here and click on close. Come and click on close. Now when you click on close, we'll right click and click on arrange all steel bar. Come here and click on update steel bar. We'll left click on it. When you left click on it, you can see now this is our slab strip, the one we did earlier on. Now you can see we are using diameter 12. This is okay at a spacing of 250. You can see in both direction we are using H12 at 250. So this is it. So after this, we can go on and design for our beam. So to do that, we'll come to we successfully designed for this slab to transfer the load to our foundation beams. So we'll come to analysis. No, we'll come to concrete design, come to beam. You come to foundation beams, not story beam, foundation beam. We have already designed story beam. Foundation beam, we'll left click on it. When you left click on it, it's going to show you that none of our beams have been designed. So to do that, because if you don't do this that I'm going to show you now, you will not be able to design your foundation beam. So to do that, we'll come to setting and parameters, left click on it. When you left click on setting and parameters, we are going to make little change here. Now I've already done a raft foundation design here, that's why you see all of these changes are here. But if you're designing raft foundation for the very first time, your concrete cover, this beam top edge is not going to be here. This beam bottom, this place is going to be empty, so you're going to be the one to put this concrete cover based on, depending on the template you're using, whether it's a BS 8110 template or an EC a Eurocode 2 or template you're using. So for this, I'm taking my beam top edge should be 36 mm and my beam bottom edge should be 50, my section side to be 36. So when you're done with this, we'll come here. Don't leave all of this in the way they are. We'll come to parameters. When you're in parameter, this is the minimum links 8, this is my maximum links 8. I will still choose 8. Now this is my minimum foundation steel bar. Minimum I will choose 12. Maximum foundation steel bar I will choose 16. Then my web steel bar I will choose 16. My minimum hanger bar diameter I will also choose, I will leave it on 16. So after this, if you don't do this thing, your beam is not going to design. If you don't do this, your beam is not going to design. I'll click on save. Now when you click on save, you can now come to beam design. When you come to beam design, you click on this, check steel, select new steel when previous bars are insufficient. You now click on calculate. Now when you click on calculate, it's going to design all of the beams and anyone that, now you can see our beam has been designed successfully, and I'll just click on cancel. Our beams have been designed successfully and none failed. None of our beam failed. So after, when the design is completed, you are now going to do an interactive design. Interactive design, as you, a structural designer or a civil engineer, is you checking your structural elements. Let's say the beam, since is what we are designing, and checking them one by one to see that the steel reinforcement that the or the bar size that the software used for the design that made it pass is appropriate. Because you know this is a software, and sometimes the bar size that pass might not be the adequate bar to use on site. So when your designs are complete, try to do an interactive design. So I'll double click on this and you can see this is okay. We're using 16 y16 throughout, y16 two number of y16. These are my sidebars. Now whenever you're designing any beam that is more than 600 millimeter, some people tell you 700, some engineers tell you 700, but whenever you're designing anything that is above 600 mm, you're going to need to provide sidebars. And you also refer to them as deep beams. A 600 or a 1 meter beam can also be referred to as a deep beam. 600 depth beam can also be referred to as a deep beam, and we'll provide sidebars for it to take care of the tensile and compression forces. So click on OK, double click on this. You can see it chooses 16. Click on OK, double click on this, click on OK. So from here you can click a design report or a summary table. Now these are summary table. Let's cancel out. You can also get a design report, print beam load, print or shear force diagram. Click on this. Please wait. Now you can see these are our beam reinforcement design. This is going to give you all of the details you need to know. If you will need to export it to Word or to PDF, you do that. It's not difficult. So for me, I don't want to do that, so I'll just cancel out of this. You can also get a bar list. This is a bar list or reinforcement table. So I'll cancel out of this. So you're going to check all of these beams. You can see this is okay. Y16 throughout. This is 16 to correct. 16. So just try and go through everything. I don't want this video to be too long, so that it won't be too boring to you. So just go through everything, click on it one by one, do a proper interactive design. When you're done, you can click on close. So this is all about the beam, the foundation beam. So let's come to the slab concrete design. We'll go to slab analysis and design. Don't click on all story, just let it work on this foundation floor. So check design, do not modify existing steel. Design, click on design and allow it to design everything for you. So it has design, and what you should be looking for is, you can see everything is written sufficient. That means all of our slabs have passed. Our slab design have passed. If your slab is failing, it's going to write insufficient here, and once you see insufficient here, it means that you're going to redesign. So this is just all about slab design. This is all about raft foundation. So from here, you just go to your Prota detail and export your raft to Prota detail and your foundation beams. We've come to the end of this. So from here, you can also choose to save this thing on Word. Can open it. Okay. Why is it not showing? The new one to replace it? Yes. We can choose to open it on Word. Now this is it here. You can choose to open it on Word. So I'll close out of it. You can choose to open it as a PDF. Save. It's going to open as a PDF, you can see. So this is everything about the slab. This is beautiful. So this is it. So just cancel. Our slab has been designed correctly. So this is just it. So this is all about so after the design, you click on cancel. This is all about designing of raft foundation. So thank you very much.